All right, before we jump in and get into formulas and the bulk of what we're going to be working on for this section, I just want to do one more kind of intro example just to make sure this notation piece is clicking a little bit. So I'm starting with just a function described in words. You don't have a formula, you don't have a graph. I'm just going to give you some information about the function, and we're going to interpret its meaning in the context of this problem. So we are given a definition of b equals n of t. Excuse me. So our function name is n, and it is inputting t values and outputting b values. And they've defined for us what those variables, the input and output variables, represent. So b is the number of birds in thousands migrating through Washington. And T is the number of years after 1990. So 1990 is sort of like a starting point for us. That's year 0. And then T is the number of years after that. So first thing, we get a statement to pick apart and describe. And I want you to really take to heart this everyday language piece. I'll try whenever I can to ask questions like this, explain what it means, because it's great if you can do the math, but if you can't then understand what your answer means in the context of a problem, it's not very helpful for those of us who are going on to be science majors or something like that, which hopefully most of us are, because that's kind of who this class is targeted at. So this says that the function n pairs the input 7, which means 7 is a t value because that's what n inputs, with the output 9.2, which means 9.2 is a b value. So it doesn't matter that we've got this written in the opposite order. We had b equals n of t, and now we have n of t equals b, basically. Doesn't matter what order that's written in. What really matters is what's in the parentheses. That's always your input. What's on the opposite side, that's always your output. And it will also tell you the function name, which sometimes is kind of boring if you're only working with one function, but can be really useful and powerful just for being really clear about what information you're giving. Okay, so the explanation piece of this, I would then say that 7 years after 1990 is 1997. And the 9.2 is the number of birds migrating through Washington in thousands. And this is where that everyday language piece is important to me. I don't think 9.2 thousand is something you would hear in everyday language. We do that a lot with millions or billions, 1.5 million, but we don't generally do it with thousands. So I would like you to try to think about that. Same thing with not writing 7 years after 1990. Go ahead and say 1997. Try and put this as plainly as you can. So I'm going to say 9,200 birds. So to put that all together, if you were going to explain this for me on a test, I would love to see something like complete sentence. In 1997, 9,200 birds were migrating through Washington. That would be an excellent explanation. In general, I am looking for that complete sentence. I am looking for you to give me the numerical values in the sentence. So don't just say, this tells me how many birds were migrating in 1997. Tell me it's 9,200. Don't leave those numerical values out, and also don't leave the units out. Those will all be important to me. So again, in 1997, 9,200 birds were migrating through Washington. It doesn't have to be exactly that wording, but that has all the pieces that I would be looking for. And then just to sneak it in here, this again is something we'll focus on more later, but I just want to start introducing it right away. Part B is asking me to find an average rate of change from t equals 7 to t equals 9. So we can even refer back to the formula. It says plug the 9 into your function, so f of 9, but we're really calling our function n. So we want n of 9 minus, plug the 7 into your function, n of 7, over 9 minus 7. That's how it would look in function notation. But again, really what that means is slope. It's the slope between 2 points on something that's not necessarily a straight line. That's when we use average rate of change. It could be curved, so the slope could change depending on which 2 points you pick, but it's still basically a slope calculation. So n of 9, that's why we were given this extra little bit of information here. We need 2 points to do this. So we're going to take the y value 6.1, and we have to subtract off the n of 7, which we were given in the first part. The y value when t equals 7 was 9.2. And then we're dividing by 9 minus 7, which is 2. So it looks like negative 3.1 over 2. And you could interpret in that form, but I would say generally we want to go down to a unit rate. We usually want to go down until our denominator is 1. Maybe not always, but that's kind of a typical thing to do. So just go ahead and do that last little bit of division, which is negative 1.55. And if I just ask you what is your average rate of change, that's a perfect answer. So the average rate of change is negative 1.55. This is in the context of a word problem, so units would be nice. If we think about what we had, the numerator was telling us about the birds, so this was thousands of birds, and the denominators were both years. So the units we're getting are 1,000 birds per year. So that would be nice. If we're then going to go the extra step and do the full explain its meaning, so always we want units, but sometimes we want an even more thorough explanation. I would say then we actually maybe want to think about it back as a fraction. It helps a little bit. So remember, average rate of change is like a change in y, which for us is the b value, over a change in x, which for us is the t value. So this is saying for every 1 year, and the units kind of captured that for us, the bird population is decreasing by 1,550. But we have a little bit of extra info in there. We don't expect this to always be true because we can't assume that n is a linear function. So we would say that this is valid between year 7 and 9, so 1997 and 1999. So I'm going to actually write this one out. Between 1997 and 1999, the number of birds migrating through Washington was decreasing by 1,550 birds per year. And I'm even going to throw in one last little phrase for this one. Again, we'll come back to this. So think about it for now. It ties in. It's very close to our slope interpretations. And it'll show back up really soon with these little bit messier ones. But we do need a little bit of extra information for this one that we didn't need for just a plain old slope calculation. And that is the fact that this is valid for a specific time interval. It may be pretty accurate for a little ways outside of that interval, but we don't expect that rate to stay the same. And also that it's an average. It's not a constant rate of change. This is an average over that interval. All right, so a little bit on interpreting functions.